Welcome back, everybody. Throughout this series, we've been throwing around the word expression, like, oh, here's an expression, or just throw an expression in here. And we've been also talking about operators, but we haven't really gone through the process of defining these in detail and explaining them in a little bit more depth. All right, so let's talk a little bit more about expressions. Well, the first thing I wanted to talk about is there are some concerns when you mix data types inside of an expression. So for example, let's say int x is equal to 5 divided by 2. So in this situation, we have an integer 5 and an integer 2, and we're storing it in an integer x. So there's no blending. Oh, come on, Claire, seriously? It's been like 4 years. So there's no blending of data types here, they're just integers. What you should expect to get is the value 2, and it helps if we output it, right? All right, so we get the value 2. Now, the thing you need to know is that if we were to switch this to a double, we're still going to get the value 2, it's just going to be stored with the .0 at the end, 2.0. And the reason that is because we are doing math with an integer and an integer. So this division is using integer division. So imagine you can only use whole numbers. So I always think about it, hey, I have 5 slices of pizza. I have 2 people to split it amongst. So I hand each person 2 pieces of pizza, and that leftover one, well, we can't split it in half, right? That's just bad. You just don't split pieces of pizza, right? So you have to throw it away, right? And as a result, each person only gets 2 pieces of pizza. So if you wanted to get 2.5, which would make sense, there's 2 ways you can do that. You can go in here and put a .0. So what's happening now is we are taking a double and dividing it by an integer. And what's going to happen is it's going to use double division. So now you can cut that last piece of pizza in half and split it amongst the people. And as a result, you get 2.5. The second way to do this is to put the keyword double right before it. Just like that. And that'll be helpful if you have a variable. For example, you might have int a equals 5. And you might have a variable here, right? But you can't do a.0. That doesn't make any sense. And you're going to get a compiling error. So instead, you just need to put that double right in front. There we go. And we get 2.5. So the important thing to know here is that double is an example of an operator, similar to like the plus sign we've used. But it only works on one operand. So if you do something like 5 plus 5, well, this is going to take one operand and add it to another operand. So it uses 2 operands. This one is only going to use one, which is the thing directly to the right of it. So the A. So the operators that use 2 operands are known as binary operators. The ones that use 1 operand are known as unary operators. So this is a unary operator, and it's important where you put this thing. For example, you might think, oh, hey, we could just use double division for this whole thing. But it doesn't really work that way, because what's going to happen is you're going to get 5 divided by 2 using integer division, and then it's going to be cast into a double. It doesn't work that way. So you get 2. Bummer. So yeah, you got to keep it like this. So my rule of thumb, just for safety, is I always try to make sure all the operands are of the same data type as the result I'm trying to get. In general, I mean, I'm not like super strict about it, but if I'm trying to get a double as the end result, it's probably best if I just go in and make all these double, even if it's not even necessary. Because I'm still going to get the same result, but now I know that I'm not going to make any mistakes. This really only matters if you're doing something like division. Like for example, if I'm multiplying here, it's going to be the same exact thing if I use the 2 or the 2.0, right? So there's no sense in me going in there and putting in .0s or casting everything to doubles. Now the next thing I wanted to talk about are some of the other operators we could use. So we've talked about some of them. I'm just going to make a comment section, and here's how you do that. We have the addition sign. We have the minus sign. Oh, this isn't going to work, dang it. Plot twist, I can't put a / because then it ends the comment. Anyways, you need the /, that's the division. And then we have the asterisk, which is multiplication. So find all those characters, make sure you understand which one's which. And then we have a special one, which you may or may not have heard of, the modulus operator. And what this is going to do is it's going to give us a remainder. So if we go back to that example we had, which I probably shouldn't have deleted it, but it's all good. We just say int x equals 5 divided by 2. This gives us the result 2, right? Because it's doing integer division. So there's actually a remainder if you think about it. Because, you know, one person gets 2 slices of pizza, the other person gets 2 slices of pizza, and then we have to throw the 5th one out. So if you want to get that remainder, instead of using this division, you use the modulus operator, which is capital 5. This should give us 1. And there we go, we get 1. This seems kind of useless, like why would you ever need that? But there's actually a lot of useful things you can do with the modulus operator. It's kind of quite magical, honestly. Now when it comes to precedence, this is the order in which things get evaluated. The division, multiplication, and modulus all have the same precedence, meaning they get evaluated first. So if you have 5 plus 3 divided by 2, this is going to get evaluated first. And then whatever that result is going to get evaluated with the 5. And it's from left to right. So if we have a multiplication right after that, well, this one's going to get evaluated, and then this one's going to get evaluated. So if you need to force precedence, you can use parentheses. So if I need this addition to go first, we could do that there. And sometimes it's helpful just to put the parentheses there even if they're not required, because that's totally okay too. So if I needed to add some extra parentheses in here, that's fine too. After that, the addition and the minus come up in precedence. So once all the division, multiplication, and moduluses are evaluated from left to right, then we go from left and right again for addition and minus. Now the next thing I want to talk about is the increment and decrement operator. So I'm going to get rid of all this junk, and we're just going to create a variable and give it the value 5. And what we can do is we could say x plus plus. And this is going to increase the value of x by 1. So if we output this, we should get the value 6. And we do, yay! The same thing can be done by decreasing the value using x minus minus. And let's output this. It should be back to 5 now. So the important thing to note here is that when we use the increment and the decrement, it changes the variable value. The other operators we talked about didn't change anything. For example, if I do double x and cast it to a double, well, that's just changing the value in the expression. It's not actually changing the variable because, as we mentioned, Java is a statically typed programming language, so that means it's always going to be an integer. Same thing if we do addition, if we do x plus 5, well, this doesn't change x, it just changes the expression. So if we're assigning this to something, the value will be 5 higher, but x always stays the same. The increment and decrement are different in that the variable value is changed, and that is super important. Now there's another variation, which is the prefix increment and decrement. So I could do plus plus x and minus minus x. In this situation, they work exactly the same way, so it's just a preference here. Now the difference comes up if you're using them inside of arguments or inside of an expression. So for example, let's just start fresh, all right? And we're going to create a new variable a and assign it the value x plus plus. Now we're going to print out both of these, just like that. And let's run it. So we get 6 and then 5. So you can see the value of x is incremented, but the value of a gets the original value of x, which is 5. So what's happening is first this x gets assigned to a, it gets the value 5, and then x is increased. The opposite happens with the prefixed versions. So if we run this, we get 6, 6, because first x gets incremented to 6, and then the value 6 gets assigned to a. So we print 6 and then 6 again. Awesome, and now the last section of operators I want to talk to you about are assignment operators. So you can see the most basic one right here. 5 is assigned to x. This is the assignment operator. Well, there's actually some different versions. So for example, I could say x is plus equal 1, and this is going to increase the value of x by 1, similar to the increment operator. And what's going on here is we're basically just saying x is equal to x plus 1. So this is a shorthand for this. You can do either one. This is a little bit more flexible than the increment operator because I can change the value here. So I could increase it by 20, I could increase it by 200, I could decrease it by 200, I could even multiply it by 200 or divide it by 200. I can even do the modulus to assign the remainder to the variable. So those are some different operators you can try out. I encourage you just to experiment, see what kind of values you get, and see if they were what you were expecting.